All right. So now we have the cohort. We have the study data, we have the cohort. But let's say that in this cohort, we're going to have the patients of all the age range. And for our study, we are only going to include patients with an age of 18 at the admin date. So to do so, we have this cohort. We have to link it back to the hospital data. In this cohort, we're going to have the patient's date of birth. And in the hospital data, we will have the date of admission. So according to these two dates, we can calculate the age. So for all the records before the patient reaching age of 18, we're going to exclude these records. So basically that is what we're going to do in this step. So I'm going to add a new procedure, and this time I'm going to call that step B, right? But step B is about further narrow down to the useful hospitalization records. It involves many steps. For this one, to apply the age exclusion criteria is just one of that. We're going to call that B1 or BA. And this is what we're going to call adults. Hospitalization of adults who are above 18 years of age. Right? So this is the program. I'm going to put the program here. So because it is too long, I'm going to move it to the second row. So again, even if you move to the second row, you still can connect it there. Anyway, so in this program, I'm going to add a step. It's called a comment. It's going to be A. So select the hospital records. When patients are 18 or above on admin date. So that's the task. All right, so where are our data? So the first is that, of course, we're gonna use the print to look at our cohort. We can also use the print to look at the hospital data. The hospital data is called data cost. Just to have an overview of what the data looks like. Okay, so the cohort is like this. We have the KHSN, we have the date of birth, and the hospitalization. In the hospitalization, we have the admin date, we have the discharge date. Right? So why we have to combine these two tables together? Because remember that in the cohort we have excluded some of the patients because their birth information or sex information is not correct. So we have to combine these two, only keeping those patients appear in this cohort, right? And then we're gonna apply their date of birth, and then we're gonna calculate it from there. So that's the idea. All right, so now we're gonna connect the two tables together. So we're gonna combine so the cohort and the data cost file together by HSN. Okay, so that's what we want to do. We're gonna combine that. and keep records of patients in the cohort table. In okay. So this is the comment. So how are we going to do it? So we're going to combine the two tables together. So again, like I said, that proc seeker will be used. Proc seeker, unlike the other procedure, it quit instead of run. So the first part of that is the same. So to create a table, then we have a one. Is that first step, right? So we have the table name, blah blah blah, and then it should end with a semicolon. So we're gonna create a table. The table is called BA because this is the program BA1, right? It has an underscore before that to indicate it is a table. So we're gonna create that as what? So it's always the same trick. The first is that we're gonna select some variables or columns. Then we're gonna state that from which source data set, and that's it, right? So what are the variables we're gonna select, right? So imagine that there are two tables. The first table is what? The first table is uh, the KHSN, the cohort table. The second are hospital records, right? So we want to keep everything from this table, all the columns from this table, right? And plus the DOB information from this table. Okay, so let's say that we're gonna from two tables. The first table is cohort. This is the first table, all right? And then we're gonna have the second table, which is called, sorry, should specify the directory or the library. So you're gonna have the second table, which is the data cost. Okay, so these are the two tables. Um, and so these two tables, and later we're gonna specify like for this cohort table, from this cohort table, what are the variables we want to have, which is the POB, right? And from this data hospital, what we want to have is everything. If it is everything, we put a star in there, right? So that's how it is going to do. But the problem is that we are not going to have the whole name of that because it sounds like it's clumsy, right? So we're going to have a nickname for this table. Let's call that table one. Yeah, you can put whatever you want. You can call it A, you can call it X, Y. You can call it T1, T2, A or B. It doesn't matter. So in my case, usually I'm going to call that T1 and T2. So these are just to give a nickname of these two tables. And now, because I give a nickname of that, I can say this is from T1 dot DOB, which means that, so from T1, you get the DOB, right? So then from T2, you're gonna have everything, all the columns, all right? So just to make the order right, I'm gonna move this T1 down. So it is going to follow the order of these columns, and at the end it's going to add a column called a DOB. All right, so I'm going to put that in this order. So this is the way to express if you want to select variables from different tables. Okay, so now from these two tables, but these two tables should be combined by the conditions, right? So these two tables should be combined or joined together. So in the correct sequence is called a join. So what kind of join? There are different types of join. So if we want to have all the patients, let's suppose that uh, these two data sets are having overlapping number of patients. You know, some of the patients are in both of them. Some patients only in this one, some in this one, right? So in that case, you can have different join types. So one of that is if you want to have uh, only those ones appear in both of the table, you should say inner join. So for this join, actually it has different types. It can be left join, which means I'm going to have all the patients from this table, but not this table. Yeah. So I can have right join, which is the flip side. I'm going to have all the patients or all the records from this table, but not from this table. But in this case, we're going to have an inner join. So the patient has to appear in both of the data sets. All right. So let's say that it's going to be an inner join, right? So these two tables are going to be inner join, but in join on what condition? So the other join is that there should be a link on it. So the other join is that, so in both of the tables, or in table 1, there is a key HSN. Table 2, there is also a key HSN. And these two key HSN should be the same. Right? That's how it is joined. So basically, this part is to say that we want to join these two tables, and we want to select the records of patient's ID appears in both of the table, and we want to link the records together according to the key HSN. All right. So that way, for example, this is the patient 001, and this patient is going to have this record, and its DOB of this patient will be added at the end of the record. So for patient B, it's going to have the corresponding DOB there. So this is the concept and how it is linked. Right? So this is the process to combine these two tables together and have the variables or columns from the different tables. Now let's just run it. All right, so now we have the results. So we have all the records of the hospital one, and then we're going to have in the end, because there are too many records, I don't know if I can reach the end of that. Something like I cannot. But anyway, so it only shows that because there are too many columns, it's not going to show us the last column. But anyway, I'm pretty sure that the DOP is there. Okay, so this is the step one. So this one we combine them together. We have the DOB there. So the second is that with this data, we want to calculate the age, right? So to calculate age at on the main date. So how to calculate that? So we're going to create a new data set. It's going to be 2 from PA1. At this time, we're going to calculate the age. So to calculate the age, we have a function, and the function is called year difference. It's called a year difference, YRDIF. So this function works like this. So the first is that you're going to have the start date. In this case is the DOB, right? And then you're going to have the end date. And in this case is the admin date. But be careful because this admin date is in date time format, whereas this DOB is in date format. So we need to change this to date part of admin date so that now these two are comparable because they are all in date format. All right. So the start date and the end date. And then you're gonna tell the function what type of year difference you're looking for. So in this case, we're gonna say age. So this is a type of year difference that a function will recognize and will calculate. So what is the special thing about this age type? So basically the age type is taking into account the leaping years. So imagine that some of the years are going to have a February 29, but some of the years only having the February 28th. So it is going to take care of the leaping years and have the age calculation correct. So anyway, so this is the function to calculate the age. And we're gonna create a variable name or column name of that. Let's call that age at the main. All right. So this is going to give us an age. So sorry, I made a mistake. It should be from one to create the two, right? Okay. So let's just run it. Yeah, I think here that we're going to have the same problem because this this view of data set is not efficient. It can only view a bunch of data set, the variables, but not all of them. So it ends up that despite we have added new columns, we cannot view it. So to change that, we can rearrange the order of the variables. We can put a retain, which is to rearrange the column. So we can retain like this. So the first column should be the HSN. The second column should be UOB. The third one, age at the name. We're gonna retain this. The rest of that, whatever order, we don't care. So we're gonna run that. And that way it is going to be rearranged. And let's see what's gonna happen. Okay, now we can see that the first column KHSN, the second DOB, date of birth, the third is the age. Actually, the age are not integers. They're with decimals. Well, we have to be careful here because, in many cases, when we talk about age, we should keep the decimals because this is more precise when later, for example, you're going to do meta-analysis. So we're always going to keep the decimals. But at the same time, we can create a different variable, right? And this time we're going to have integers or int of this age. So this is for example, illustrate categories that makes more sense, right? So these two serve for different purposes. And we're gonna also put order it in the beginning for the column at the beginning of the data set. Okay. So by doing so, we added two columns. One is the age with decimals. The other is age with integers. Okay, so these are the ages that we have for these hospital records. now we have those hospital records. We already have the age on the admission date. Well, so going back, and you might have a question saying, hold on. So we have seen that in the original record, you already have a born year, you already have a born month. So it seems that you don't have to have this COB from a second file. Why don't you just directly apply that? So I have to say that this is correct. All right. So I'm doing that just to make an example to show you how to combine the tables together and have variables from different data sets. In this case, well, probably, we don't have to do that. But anyway, you get the idea. Okay, so now we have the calculation of the age on the date. And the next is that we are going to exclude those hospital records, exclude hospital records when patients were less than 18 years old on the date. Okay, so yeah, also call it were. Yeah. So how to do that? We're gonna have a target data set. Let's just put a name later. Let's just call that, well, it's 3, right? And this time, um, so we're gonna get the data from this B2, and we're gonna apply a condition, which is where this integer, this integer is. So there are different ways of putting that. So if you are going to follow this, you can say not um, less than 18 or less than 18. So that is one way to do that. The other is that you can also say where this is greater or equal to 18. Right? So equally, that would be the same. And we can also say it is, to use different symbol, we can say greater or equal. So this GE is the same as that sign, greater and equal sign. Okay, so we're gonna put it like this. And then we're gonna run this data set to have the result. So imagine what are we gonna have? We're gonna have the hospitalizations of when the patients were um, 18 years or above on the admission date. Let's just change that to keep the hospital record when patients were 18 or plus on admission date. We're also going to change this to select patient rating plus on the admission date, right? So because this is pretty much the final data, so we're going to put that in the permanent library. We're going to call that BA instead of the B3, right? We're going to run that. And we have the final data set. Okay, we have the final data set. All right, so now we're almost done for this step. The only thing we can do is that finally, with this final data set, we are interested to check the age distribution of this hospitalization. This is just for fun, all right? To check the age distribution, we're going to use a procedure called the univariate analysis. Basically, it's like a univariate um, linear, regression models. So it's univariate analysis. So we're going to use the data as the TA, which is the data we just created. And we are interested in the age as integer at the name. So by the way, I might change that. It should call that age as the name. It should call age on the name. I don't know. So like that one is more correct. All right. So age on a name. Yeah, so age on a name. Okay. So we're gonna have the variable called age on a name. And we're going to make a histogram of this variable on the vein. Right? We're going to run that because we've previously I've changed the name, but I'm going to rerun it from here to the end. But the result was not produced, and I checked the log. I found that actually I typed it wrong. So it should be univariate, but it's univariate. What is that? So I should change that to univariate. Run it again. Histogram is so this typing happens all the time. Histogram. Yeah. Okay. So run it again. And no observations in this. Well, then check this PA2. So this one is not calculated, it's missing. So what happened to this line? The name should be on the name instead of added name. So now this PA2 should produce the right result. Yes. And going back, and we're going to do this part again to keep the records when the patient was 18 years or above. Yes. And then finally, we're gonna make this univariate form. All right, so that is the result. So the univariate. So what we are interested is to check the distribution of age on this chart, which is the histogram chart. Yeah, so we can see that the age is ranged from, of course, this is dummy data. It does not make any sense. It sounds that it across all the age groups. But I just wanted to get the idea on how to do a histogram. It's quite common. You can also have an option here which is called a novel. So basically what it does is that it's going to overlap um, a normal curve on it so that you can have the idea on the distribution and see whether or not it is following the normal distribution. In this chart, it is not at all. Right. Anyway, of course, this makes sense because these are dummy data, right? But you just get the idea on how to create this distribution stuff. Okay, so that will end this part, which is the BA, which is the hospitalization. So now So in this section, we have 3 steps more. We have the study data, we have the cohort, and we have the hospitalizations with selected age group. Okay, so we're gonna connect that together. Well, I would say that Sas did a great job in this kind of linking lines, right? Look at that. It sounds like it's quite ugly, but anyway, that's how it looks like. I'm gonna keep it that. So we are a bit closer to the final one, but still there are some steps in between. All right, I'm gonna stop here and I'm gonna save this file. I'm gonna close that and I'm gonna close this studio section. All right, so that's basically that's it for today. I'll see you until next time.